The Kawanishi H8K was obsolete before it touched water, at least, that is what American intelligence believed in early 1942. Japan possessed neither the industrial capacity nor the metallurgical sophistication to build a four-engine flying boat capable of reaching Pearl Harbor from the Marshall Islands without refueling, according to every technical briefing distributed to Pacific Fleet commanders. The fundamental mathematics of range versus payload seemed to forbid it. Yet on the night of March 4, 1942, two of these aircraft materialized over Oahu, having traveled nearly 4,000 miles through darkness and storm, refueled mid-ocean by submarines in a lagoon the Americans had never bothered to defend. The bombs missed their targets. But the impossibility had occurred. Before we go deeper into how this decision changed the Pacific War forever, make sure to subscribe for more history that actually happened. The paradox was not that Japan had built such an aircraft. The paradox was that American analysts, confronting evidence of its existence, chose to disbelieve their own reconnaissance photographs. When the first H8K prototype rolled from Kawanishi's Naruo plant in December 1940, it represented not merely an engineering achievement but a calculated gamble on a type of warfare the modern world considered extinct. The age of the military flying boat was ending even as the H8K took shape. Land-based bombers with comparable range were lighter, cheaper, and required no specialized knowledge of hydrodynamics. Runways could be built faster than seaplane facilities. Yet Japan, resource-starved and surrounded by ocean, committed its limited aluminum and skilled labor to perfecting a machine that existed at the intersection of ship and aircraft, that belonged fully to neither sea nor sky. The Imperial Japanese Navy issued Specification 13 Sure in 1938, a document remarkable not for what it demanded but for what it presumed possible. The new flying boat must exceed the H6K in every category, 30% faster, 50% greater range, and survivability sufficient to operate alone across the Pacific's vast emptiness. Maximum speed of 276 miles per hour. Cruising speed of 207 miles per hour. Range of 5,180 statute miles carrying a full combat load. The numbers defied contemporary aviation physics. American flying boats of similar configuration, the PBY Catalina, the PBM Mariner, sacrifice speed for endurance or range for payload. No one had yet built an aircraft that excelled at everything simultaneously. The Navy wanted such an aircraft operational within 3 years. Kawanishi's design team, led by Kikuhara Shizuo and working under intense secrecy, began with a problem that had destroyed flying boats since the type's invention: the hull. Aircraft hulls must satisfy contradictory demands. They must be hydrodynamically clean to minimize water resistance during takeoff, yet aerodynamically efficient to reduce drag in flight. They must be strong enough to withstand wave impact at high speed, yet light enough to permit useful payload. The slightest miscalculation produces an aircraft that either tears itself apart on rough water or never achieves flight speed before exhausting its takeoff run. Kikuhara's team spent 18 months in wind tunnels and water tanks at Tokyo Imperial University, testing scale models, measuring pressure distribution, calculating planing angles. They studied reports from Short brothers in Britain and examined intelligence photographs of the German Blohm and Voss flying boats. What emerged was a hull of unprecedented sophistication, deep V cross-section forward transitioning to shallow V aft, with longitudinal spray strips positioned with millimeter precision to deflect water away from the propellers at rotation speed. The hull itself measured 92 feet 4 inches from nose to tail, constructed entirely from duralumin, an aluminum alloy incorporating copper, manganese, and magnesium that provided strength-to-weight ratios impossible with steel. Japan's duralumin supply was critically limited. Every kilogram allocated to flying boats could not go to fighters or cruisers. The decision to build the H8K represented a strategic choice about how Japan would fight the Pacific War. The aircraft would patrol zones beyond the range of land-based bombers. It would locate American carrier task forces before those carriers could locate Japanese positions. It would function as scout, bomber, and command post, capable of remaining aloft for over 24 hours, covering search areas larger than Texas. The prototype first flew on July 14, 1936. No, that date belongs to the earlier H6K. The H8K prototype took to the air for the first time on December 31, 1940, with test pilot Katsuji Kondo at the controls. Within minutes, disaster nearly followed. The aircraft exhibited severe porpoising on the water, an oscillating pitch motion that threatened to bury the nose or flip the aircraft onto its back. Porpoising occurs when hull geometry creates alternating zones of positive and negative pressure as speed increases. The H8K's hull, optimized for high-speed planing, generated insufficient damping to prevent resonant oscillation. Kondo managed to coax the prototype into the air, but landing was a calculated risk each time. The water handling was, quite simply, dangerous. 3 months of urgent redesign followed. Kawanishi engineers deepened the forward hull by 11%, increasing the cross-sectional area to provide greater buoyancy and damping. They repositioned the step, the discontinuity in the hull bottom that allows the aircraft to transition from displacement to planing mode, and added secondary spray strips. 2 pre-production aircraft incorporated these changes and proved airworthy on water. But time was running out. By mid-1941, war with the United States appeared inevitable. The Navy demanded immediate production. Kawanishi built 14 H8K-1 Model 11 aircraft before the end of 1941, rushing them into service despite lingering concerns about seaworthiness. Crew training manuals included extensive warnings about water handling in rough seas. Pilots learned to read wave patterns, to time their takeoffs between swells, to land with precise sink rates that would not overload the hull structure. The power plant installation exemplified the aircraft's complexity. For Mitsubishi KC-11 14-cylinder radial engines, each producing 1,530 horsepower, drove 4-bladed propellers 11 feet in diameter. The engines were mounted in nacelles fed smoothly into the wing leading edge, positioned high enough to keep the propellers clear of spray during water operations. Fuel capacity totaled 18,880 liters, nearly 5,000 US gallons, distributed among 14 tanks. 8 small tanks nestled in the wings, unprotected and vulnerable to gunfire. 6 large tanks occupied the hull, partially self-sealing through layers of rubber compound that swelled when exposed to fuel, closing punctures of up to 13 millimeters. If a hull tank was holed, fuel drained into the bilge rather than spraying into the interior. From there, hand-operated pumps could transfer the fuel back into undamaged tanks, recovering what would otherwise be lost. A carbon dioxide fire suppression system flooded the tank spaces at the first sign of combustion. Japanese designers, often criticized for neglecting crew protection, had created in the H8K an aircraft that could absorb battle damage and survive. American pilots who later encountered the H8K nicknamed it the Flying Porcupine not only for its defensive armament but for its stubborn refusal to fall from the sky. That armament deserved its reputation. The H8K-1 carried a 20mm Type 99 cannon in a dorsal turret and another in the tail turret, supplemented by 7.7mm Type 92 machine guns in the nose and in-beam blisters on each side of the fuselage. A ventral position added another machine gun to cover the underside. The arrangement provided interlocking fields of fire across nearly the entire defensive sphere. Attacking fighters found no angle of approach free from fire. Yet even this proved insufficient. Combat reports from early 1942 revealed that enemy fighters simply stood off beyond effective range and attacked in coordinated waves, accepting losses to bring down the valuable patrol aircraft. The H8K-2, introduced in mid-1942, rectified this weakness with ruthless efficiency. It replaced nose and beam machine guns with additional 20mm cannon, adding 7.7mm guns in new side and cockpit positions. The final armament totaled 5 20mm cannon and 5 7.7mm machine guns, firing from overlapping positions that created a nearly impenetrable defensive cocoon. Ammunition capacity allowed sustained combat. Armor plate protected the crew positions and the flight deck. The H8K-2 could, and did, fight its way home through fighter screens that would have destroyed any other patrol aircraft. But firepower meant weight, and weight reduced range. The H8K-2, powered by uprated KC-22 engines delivering 1,850 horsepower each, had a maximum takeoff weight of 32,500 kilograms, nearly 72,000 pounds, half of which was fuel, weapons, and crew. At this weight, getting airborne from calm water required a takeoff run exceeding 2,000 meters. In rough seas, the run could double. Pilots learned to taxi into the wind, building speed gradually, feeling for the precise moment when the hull transitioned onto the step and drag fell away. Too soon, and insufficient speed meant the aircraft settled back into displacement mode, wallowing helplessly. Too late, and the engines overheated or the hull took punishing impacts that could crack internal structure. The margin between success and failure measured in seconds and knots. Every takeoff was a negotiation with physics and fate. Once airborne, the H8K transformed. Maximum speed of 290 miles per hour at 16,000 feet made it faster than many contemporary fighters at altitude. More importantly, cruise performance allowed missions of staggering duration. At 184 miles per hour and 8,000 feet, fuel consumption dropped to approximately 400 liters per hour. With nearly 19,000 liters aboard, the aircraft could remain airborne for over 24 hours, covering 4,400 miles, sufficient to patrol from Truk in the Caroline Islands to the approaches to Pearl Harbor and return, or to fly from the Marshall Islands to reconnaissance the Coral Sea. Navigation over such distances, across featureless ocean, required skill that few aviators possessed. The crew of 10 included a dedicated navigator using celestial observations, dead reckoning, and radio direction finding to maintain position estimates accurate to within a few miles after flights exceeding 12 hours. Drift errors of even a single degree compounded over time into navigational errors of hundreds of miles. Crews that became lost over the Pacific simply disappeared, running out of fuel beyond the range of rescue. The Japanese Navy understood these risks and accepted them as necessary. The Pacific War would be decided by intelligence, by knowing where the enemy's carriers were before the enemy located yours. Flying boats provided that intelligence. They flew alone, far from friendly forces, searching quadrants of ocean assigned at morning briefings. Each aircraft covered a wedge-shaped sector, typically 30 degrees wide and extending 600 miles from base, systematically traversing the assigned area before returning. If contact was made with enemy forces, the flying boat shadowed from maximum radar range, reporting composition, course, and speed. The information went directly to Combined Fleet Headquarters. Carrier strike forces launched on the basis of flying boat reconnaissance. The aircraft that made contact rarely survived to see the results. Enemy fighters hunted them relentlessly. By December 1941, only 14 H8K-1 aircraft were operational. The attack on Pearl Harbor employed carrier-based aircraft exclusively, but the success of that raid prompted immediate questions about follow-up operations. Could Japan strike again, demonstrating that the Pacific Fleet remained vulnerable even after the initial surprise? Standard doctrine held that aircraft carriers must approach within 200 miles of target to launch strikes. The Americans knew this. They would expect any second raid to come from carrier aircraft and would concentrate their defenses accordingly. But what if the attack came from an entirely different direction, from aircraft staging from bases thousands of miles away? The concept had elegant simplicity and daunting complexity. H-8K flying boats, operating from Watya Atoll in the Marshall Islands, could reach Pearl Harbor, but only with in-flight refueling. The distance from Watya to Oahu exceeded 3,700 kilometers, well beyond the H-8K's combat radius. However, French frigate Shoals, a tiny atoll in the northwestern Hawaiian Islands, lay almost exactly midway along the route. If submarines could rendezvous there with the flying boats, transferring sufficient fuel to top off the tanks, the bombers could continue to Oahu, strike their targets, and return to French frigate Shoals for refueling before the final leg back to Watya. The logistics were unprecedented but feasible. Japanese submarines carried aviation gasoline for their own float planes. Pumping fuel from submarine to flying boat while both wallowed in an exposed anchorage would be difficult, dangerous, and slow, but not impossible. Planning for Operation K, as the mission was designated, began in late January 1942. Naval intelligence reported that American salvage operations at Pearl Harbor were proceeding rapidly. Dry docks were being repaired. Battleships capsized on December 7 were being refloated. If these efforts succeeded, the strategic impact of the original raid would diminish. A second strike, even a small one, could disrupt repair work, destroy salvage equipment, and demonstrate that Hawaii remained within Japan's reach. The psychological impact might force the Americans to disperse their repair facilities or even abandon Pearl Harbor as a forward base. 5 H8K aircraft would participate, each carrying 250-kilogram bombs. They would target 1010 Dock, so named for its length of 1,010 feet, where several damaged warships were moored for repair. The raid was scheduled for early March, timed to coincide with a full moon that would illuminate the target area. But the plan began unraveling before it started. Of the 5 H8K aircraft assigned, only 2 were ultimately available when the launch date arrived. Mechanical problems grounded 2 others. Another was reallocated to a higher priority patrol mission. Lieutenant Hisao Hashizume would lead in the first aircraft. Ensign Shosuke Sasao would fly the second. Both crews were experienced, having logged hundreds of hours on patrol missions. They knew what it meant to fly for 16 hours over empty ocean, trusting their navigation, trusting their engines, trusting that the fuel would last. This mission would exceed anything they had previously attempted. Total flight time would approach 24 hours. There would be no alternate landing sites. If anything went wrong between French frigate Shoals and Oahu, the ocean would claim them without trace. 3 submarines departed their bases in late February, IU-15, IU-19, and IU-26. Another submarine, IU-23, was supposed to position itself south of Oahu as a lifeguard and weather observation platform. IU-23 never arrived. It vanished sometime after February 14, lost to causes unknown, possibly to depth charge attack by American patrol aircraft, possibly to mine, possibly to mechanical failure leading to catastrophic flooding. 75 men died. The operation continued. A submarine would not be missed at French frigate Shoals as long as the refueling platforms arrived. American codebreakers had been reading Japanese naval communication since before the war began. By late February, they knew that Japan was planning some kind of long-range operation involving flying boats and submarines. They knew the target was almost certainly Hawaii. They even knew the refueling location, though the message simply referred to it as AF in Japanese code. But intelligence that reaches the right analysts is useless if those analysts cannot convince operational commanders to act. The warnings were distributed. Patrols were increased in some areas. And then the warnings were disregarded. How could Japanese flying boats reach Hawaii? The distance was impossible. The reports must refer to carrier-based aircraft. Standard anti-submarine sweeps would be sufficient. French frigate Shoals remained unguarded. At 2 a.m. on March 3, 1942, the 2 H8K aircraft lifted from the lagoon at Watyer Atoll, their hulls trailing phosphorescent spray visible for miles in the darkness. Each aircraft carried 4 bombs, a full load of ammunition, and fuel sufficient to reach the refueling point with reserves. The flight to French frigate Shoals took approximately 12 hours, flown entirely over open ocean in daylight, at altitudes between 8,000 and 10,000 feet where visibility extended to the horizon in all directions. Any American patrol aircraft spotting them would vector fighters to intercept. But the patrol aircraft never came. The Pacific was simply too vast. 2 aircraft, even aircraft as large as the H8K, were invisible against the scale of ocean. The submarines were waiting as planned. IU-15 and IU-19 had arrived the previous evening and secured in the shelter of the lagoon, their decks awash, their crews preparing hoses and pumps. Refueling a flying boat from a submarine had been practiced in exercises but never attempted operationally under wartime conditions. The process took nearly 2 hours per aircraft. Fuel flowed from submarine bunkers into the flying boat's wing tanks through canvas hoses connected to fittings in the aircraft's upper wing surface. The H8K wallowed in the light chop, its wingtip floats occasionally scraping the submarine's deck. Crew members held the hose connection steady, fighting the constant motion. One kinked hose, one disconnected fitting, and fuel spilled into the sea, wasted. Every liter mattered. Finally, tanks topped off, the aircraft taxied clear, their engines idling roughly after the long shutdown. The crews ate cold rice balls, drank water, checked weapons systems. At dusk, they took off again, heading east-southeast toward Oahu, another 560 miles and 4 hours distant. The moon rose almost full, silvering the ocean. At this altitude, the curvature of the Earth was visible, horizon dropping away in all directions. The two H8K flew in loose formation, close enough to see each other's silhouettes but far enough apart that collision was impossible if one aircraft maneuvered abruptly. Hashizoom navigated by dead reckoning and star shots, verifying his heading every 30 minutes. The flight engineer monitored fuel consumption, calculating whether reserves would suffice for the return leg. Everything depended on reaching the target on schedule, dropping ordnance, and departing before American fighters could intercept. The element of surprise had already been compromised. American radar stations on Kauai had detected the incoming aircraft at extreme range. Air raid warnings were sounding across Oahu. Curtiss P-40 fighters scrambled from Wheeler Field, searching in the darkness. PBY Catalina patrol planes launched, seeking the Japanese carriers that must have launched the attackers. But there were no carriers. And the two H-8K, flying at 15,000 feet, were effectively invisible in the moonlit darkness to fighters that lacked radar and were searching at the wrong altitude. Hashizoom expected to see the lights of Pearl Harbor, the only facility in Hawaii permitted to remain lit under blackout regulations, on the theory that any attacking force already knew where it was. Instead, he saw clouds. A solid overcast deck stretched from horizon to horizon at 10,000 feet, obscuring everything below. This was not supposed to happen. Japanese intelligence had assured mission planners that March weather over Hawaii was reliably clear. But Pacific weather obeys no intelligence estimate. The same storm system that had created rough seas at French frigate shoals had pushed ahead to Oahu, bringing clouds, rain, and winds that scattered the two aircraft. Hashizoom could not see his wingman. He could not see the target. He could not even confirm he was over land. Navigation by dead reckoning placed him somewhere north of Honolulu, but cumulative errors over 20 hours of flight could easily amount to 10 or 20 miles. If he descended below the clouds to verify his position, he would expose his aircraft to every anti-aircraft battery on the island. If he remained above the clouds, he would be bombing blind, wasting ordnance against unknown targets. He decided to descend. Breaking through the overcast at 5,000 feet, he caught a brief glimpse of Kina Point Lighthouse, the northwestern tip of Oahu. The coastline matched his charts. He was exactly where he calculated he should be. But Pearl Harbor lay to the south, across the Waianae Range, and clouds still obscured everything in that direction. Hashizoom made a decision that would define the mission's outcome. Rather than flying blind over the presumed location of Pearl Harbor, he would bomb the first legitimate military target he could identify. At 2:15 a.m. local time, flying at 15,000 feet over Honolulu's northwestern suburbs, he released all 4 bombs in a single salvo. The ordnance fell through for miles of darkness and detonated on the slopes of Tantalus Peak, an extinct volcanic cone just north of Roosevelt High School. The explosions created craters 6 to 10 feet deep and 20 to 30 feet across. Windows shattered in nearby houses. Residents stumbled into the street, expecting to see the sky full of aircraft. Instead, they saw nothing. The H-8K had already turned northwest, climbing back into the cloud deck, Hashizoom advancing the throttles to maximum continuous power, heading for the relative safety of open ocean. Ensign Sasao, having lost sight of Hashizoom's aircraft in the clouds, orbited south of Oahu, searching for any identifiable landmark. He saw nothing. Fuel state was becoming critical. He could not continue searching indefinitely. At some point, possibly over the ocean near Waianae, possibly near the entrance to Pearl Harbor, the historical record is unclear, he jettisoned his 4 bombs into the water, unseen and unrecorded. Then he too turned northwest, racing the fuel gauges toward French frigate shoals. Both aircraft made the rendezvous, arriving minutes apart at first light. The submarine surfaced and again began the slow process of transferring fuel. But Hashizumi's aircraft had sustained hull damage during the rough takeoff at French frigate shoals. The hull plating cracked near the step. Salt water had leaked into structural compartments. Repair would require dry dock facilities. Watya Atoll lacked such facilities. But Jaluit Atoll, deeper in the Marshall Islands chain, had a full seaplane base. Hashizumi made the decision to bypass Watya and fly directly to Jaluit, non-stop, adding another 800 miles to an already record-breaking mission. His crew had been in the air for over 24 hours when they finally touched down in Jaluit's lagoon, having flown farther on a combat mission than any aircraft in history to that point. Sasao returned to Watya without incident, landing to the cheers of base personnel who had given both crews up for lost. In Honolulu, military and civilian authorities struggled to explain what had happened. The Army blamed the Navy. The Navy blamed the Army. Both blamed improper ammunition handling, suggesting the explosions resulted from someone jettisoning ordnance in an unauthorized location. Newspaper reports, citing anonymous Los Angeles radio broadcasts, claimed 30 dead and 70 wounded at Pearl Harbor, with considerable damage to facilities. None of this was true. Total casualties, 0. Damage, shattered windows and residential landscaping disturbed by bomb craters. The military impact of Operation K was precisely nothing. But the strategic consequences were profound. American naval intelligence, confronted with evidence that Japanese flying boats could reach Hawaii from the Marshall Islands with submarine refueling, immediately recognized the vulnerability of French frigate shoals. Admiral Chester Nimitz, commander of the Pacific Fleet, ordered the atoll occupied and mined. When Japanese planners attempted to repeat Operation K in late May as a preliminary to the Midway operation, submarines I-123 found American warships anchored at French frigate shoals and mines blocking the lagoon entrance. The follow-up mission was cancelled. Without flying boat reconnaissance of Pearl Harbor, Japanese intelligence entered the Battle of Midway blind, unaware that American carriers were already at sea, positioning for ambush. The flying boat that was supposed to confirm carrier movements never flew. The intelligence that might have prevented catastrophe never reached Admiral Nagumo. Midway became the turning point of the Pacific War in part because Operation K failed to achieve its negligible tactical objective but succeeded in alerting the Americans to a capability they had not previously considered credible. The H8K continued to operate throughout the Pacific War, flying patrols of mind-numbing duration over empty ocean, locating American task forces, shadowing invasions. Aerial combat between flying boats and long-range patrol aircraft became a strange subset of the air war, four-engine giants dueling at low altitude, turrets blazing, the ocean below awaiting whichever aircraft fell first. On July 2, 1944, an H8K of the 851st Air Group encountered a PB-4Y-1 Liberator of Patrol Squadron VPB-115 over the Central Pacific. The two aircraft circled each other for 20 minutes, exchanging fire at ranges where hits were unlikely. The H8K's gunners were accurate. The Liberator's crew was determined. One of the 20mm shells from the H8K's tail turret found the Liberator's No. 3 engine. But the Liberator's .50 caliber guns had already torn through the H8K's hull tanks. Fuel streamed from the flying boat, mixing with hydraulic fluid and oil. Fire erupted along the wing route. The H8K's captain maintained control, descending toward the ocean, probably intending a forced landing. The aircraft struck the water at too steep an angle. The hull fractured. The H8K broke apart and sank within minutes, taking its crew of 10 with it. The Liberator, one engine dead and another failing, limped to its base on 3 engines, the crew exhausted, their aircraft shredded. This was the reality of long-range patrol warfare, brutal, anonymous, and decisive. Aircraft flew for hours to fight for minutes against an enemy they had never seen before and would likely never see again. Survival depended on skill, luck, and the marginal advantage of better armor or more accurate gunfire. The H8K, for all its defensive firepower, remained vulnerable to concentrated attack. American fighter pilots learned to coordinate their passes, accepting the first man in would likely take hits in order to distract the gunners while the following aircraft attacked from another angle. Damaged H8K aircraft faced an additional hazard, forced landing on the open ocean. The hull might survive the landing, but without rescue, the crew would drift until food and water ran out. Japanese doctrine included provisions for these situations: survival equipment, emergency rations, navigation charts showing currents and probable drift. Yet Pacific Ocean currents could carry a drifting aircraft hundreds of miles from the point of ditching. Rescue chances diminished with every hour. Production of the H8K totaled 167 aircraft, built at Kawanishi's Naruo and Konan plants between 1941 and 1945. This was fewer than 1/20th the number of PBY Catalinas produced by the United States. Japan's industrial capacity, stretched across fighter production, carrier construction, and cruiser completion, could not support mass production of large patrol aircraft. Every H8K required skilled labor, precision machining, and materials increasingly scarce as the war progressed. By 1944, aluminum alloys were diverted to fighter production. Kawanishi proposed building flying boats from wood and steel to conserve strategic materials, but the designs never advanced beyond mock-up stage. The H-11K Soku, a projected cargo flying boat built almost entirely from non-strategic materials, reached full-scale mock-up in early 1945. American bombs destroyed the mock-up on April 1, 1945. The project was abandoned. By mid-1944, changing operational requirements had rendered the long-range flying boat obsolescent. American submarines were sinking Japanese merchant vessels faster than they could be replaced, strangling the supply lines that allowed distant bases to operate. Flying boats required enormous quantities of fuel and munitions, delivered by tanker and freighter. As those vessels disappeared, the far-flung seaplane bases became untenable. Aircraft were withdrawn to bases closer to Japan's shrinking defensive perimeter. The H-8K, designed to patrol the vast expanses of the early war Pacific, found itself relegated to shorter missions within range of American carrier aircraft. Losses mounted. Replacement crews were less skilled than those they replaced. By early 1945, most remaining H-8K aircraft were being converted to transports, carrying critical supplies and personnel between islands that the Americans had bypassed. The VIP transport version, the H8K-2L, seated 29 passengers or 64 troops in relative comfort, because the aircraft was unpressurized, unheated, and subject to violent turbulence at the low altitudes required to avoid interception. But it could fly where merchant ships could not, threading through blockades, landing in remote lagoons under cover of darkness, departing before dawn patrol aircraft arrived. The last H-8K combat mission was flown in July 1945 from a base in the Inland Sea. The war ended 6 weeks later. Of 167 aircraft built, fewer than 20 survived to surrender. American occupation forces located intact examples at several bases. One H-8K-2, construction number 426, was selected for evaluation and shipped to the United States. Navy test pilots flew it from the Patchesant River Naval Air Station in Maryland, pushing it through performance trials, assessing its handling characteristics, comparing it to American flying boats. Their reports expressed grudging admiration. The H-8K was faster than the PBY by 60 miles per hour. It was more heavily armed than any American patrol aircraft. Its range, while not matching the inflated claims of Japanese propaganda, exceeded that of the PBM Mariner. Water handling remained tricky. The American pilots noted porpoising tendencies at certain speeds and warned against rough water operations, but in flight, the aircraft was stable, responsive, and pleasant to fly. The engines, though less powerful than comparable American radials, were reliable and fuel-efficient. Visibility from the flight deck was excellent. The dorsal turret had better fields of fire than the American bull turret. In summary, the H-8K was one of the finest flying boats of the war, possibly the finest, limited only by the industrial constraints that prevented Japan from building enough of them to matter. Aircraft historian René Franzillen called it the most outstanding water-based combat aircraft of the Second World War. This was not hyperbole. It was recognition of the engineering sophistication required to balance speed, range, payload, and survivability in a platform that operated from an environment inherently hostile to aircraft. Metal corroded in saltwater. Algae and barnacles fouled hulls. Waves imposed structural loads that no land-based aircraft ever experienced. Maintenance requirements were staggering. Each flight required inspection of hundreds of hull rivets, checking for cracks, corrosion, or looseness. Fuel system integrity demanded constant vigilance. One leak, one fouled valve, and the aircraft might not return from its next mission. The crews that flew these aircraft understood they were operating at the edge of what technology permitted. The sole surviving H8K, construction number 426, spent decades on outdoor display at the Maritime Museum in Tokyo, exposed to weather, salt air, and pollution. The aircraft deteriorated visibly, its metal surfaces corroding, fabric surfaces disintegrating, plexiglass clouding. In 2003, it was relocated to the Kanoya Naval Air Base Museum in Kagoshima Prefecture, where climate-controlled storage halted further decay. Restoration efforts continue, but the aircraft will never fly again. Too much structural integrity has been lost. The engines, stored separately, are inert museum pieces. The fabric control surfaces have been replaced with modern materials that approximate the original appearance but lack period authenticity. What remains is a monument to an idea that briefly worked, that aircraft could extend naval power across distances that ships could not cover in time to matter, that the ocean itself could be a highway for machines light enough to escape its surface yet capable enough to survive its emptiness. Operation K, the mission that demonstrated this capability and simultaneously revealed its limitations, remains largely forgotten. No one was killed. No strategic targets were damaged. The bombs fell on a residential hillside and were forgotten within weeks. Yet the mission's consequences rippled outward, shaping decisions that led to Midway, altering American perceptions about Japanese technological capabilities, forcing defensive investments in remote atolls that otherwise would have remained ignored. The two H8K crews that flew through darkness across 1,000 miles of ocean, refueled from submarines in an undefended lagoon, and bombed a target they could not see, achieved something more important than the destruction they failed to inflict. They proved the concept was viable. That proof was enough to change how both sides thought about the Pacific War's geography. The H8K itself became a victim of its own capability. It was too complex, too resource-intensive, too demanding of maintenance and skilled crews for Japan's shrinking industrial capacity to sustain. Every hour the aircraft flew required dozens of hours of maintenance. Every mission consumed fuel and munitions that could not be replaced. As Japan's merchant fleet evaporated under submarine attack, the supply line supporting remote flying boat bases collapsed. Aircraft sat idle for lack of fuel. Crews waited for spare parts that never arrived. By war's end, the sophisticated fuel recovery system, the self-sealing tanks, the carbon dioxide fire suppression, the overlapping fields of defensive fire, all the engineering brilliance invested in making the H8K survivable, became irrelevant. The aircraft died not from enemy action but from logistical strangulation. There is irony in this outcome. Japan built the H8K to compensate for strategic vulnerabilities, shortage of aircraft carriers, inadequate number of bases, impossibility of projecting power across the Pacific's vast distances with existing aircraft types. The solution was technically successful. The H8K could, in fact, cross the Pacific, operate independently for 24 hours, and return. But the solution was strategically irrelevant. The Pacific War was decided by carrier battles fought within 300 miles of opposing fleets, not by patrol aircraft operating at extreme range. It was won by industrial capacity that could replace losses faster than the enemy could inflict them. Japan built 167 H8K aircraft over 4 years. The United States built over 100,000 aircraft in 1944 alone. No amount of engineering sophistication, no degree of crew skill, could overcome that arithmetic. The H8K was obsolete the day it was born, not because its design was flawed, but because the type of warfare it was designed to fight had already been superseded by a conflict that would be decided by industry, logistics, and attrition. The aircraft that could fly 4,500 miles and fight its way home was ultimately irrelevant because there was no home to return to. Bases were captured or bypassed. Fuel supplies were interdicted. Replacement crews were lost in training accidents or killed on their first missions. By 1945, the H8K existed primarily as a curiosity, a technical achievement that proved what was possible but could not alter what was inevitable. One detail remains: the bombs Lieutenant Hashizoom dropped on the slopes of Tantalus Peak that night in March 1942 were never located. They detonated on impact, as designed, but the fragments scattered across residential yards, gardens, and roadside vegetation were never systematically collected. For decades after the war, residents occasionally found corroded metal chunks while gardening, often discarding them without recognition. A few pieces survive in local collections, labeled simply Operation K debris. They are anonymous, unremarkable, shrapnel from a mission that barely happened, evidence of the night Japanese flying boats crossed the Pacific to bomb darkness and achieved nothing except to prove it could be done. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world.